Hey kids, 10.4, here we go. Inscribed angles and polygons. Main thing, what we have here, inscribed angles. So you have a circle still, you got the center of the circle O. An inscribed angle is when you have a vertex, can't use that color, it's not there anymore. So the vertex of the angle is on the circle. So this is the next step from a central angle. Okay, a central angle, the vertex is at the center. Central angle. Inscribed angle, the vertex has to be on the circle. Okay, so it has to be somewhere along the circle. So we have RQP as your inscribed angle. This terminology right here, this is what they call the intercepted arc. I've touched on that a little bit already. So it intercepts it, boom, boom, cuts it off right there. So we know already the relationship if this central angle is 160 degrees, this arc is 160 degrees, and what the new relationship here for an inscribed angle is it's going to be half of the intercepted arc. So if this is 160, half of that is 80, so that's an 80 degree angle. Likewise, the arc is twice the value of the inscribed angle here. Okay, so that was half of the intercepted arc. Half of the intercepted arc. Okay, so when you look at this one, this is page 293, by the way, 10.4. CAD. CAD, is that a central angle or inscribed angle? CAD. Well, A, the vertex is at the center, so that's a central angle. CBD, this one right here, the vertex is on the circle, that is an inscribed angle. Okay, if this is 90 degrees, this has to be 45 degrees because they intercept the same arc, which would also be 90 degrees. Okay, next page. We'll move past that. Page 295. Here's your terminology. We've talked about some of this already. The word subtend is coming up here at the bottom. Inscribed polygon and circumscribed circle, we kind of know those already. Okay, so we've already talked about this. This is where that word subtend shows up. So AC is just saying what is included within the inscribed angle. Okay, so I have angle ABC, which is an inscribed angle because the vertex is on the circle. The intercepted arc is referring to it subtends angle B. And this chord right here from A to C that also subtends A to B. Now keep in mind, if I was going to draw an angle bisector, that would make an isosceles triangle. And a right triangle, it also bisects this chord. So some of those properties from the last lesson will show up here as well. That if you have an angle bisector, if this angle equals this angle, you're going to have an isosceles triangle here. And it's going to be 90 degrees, and it's going to intercept that arc. Okay? Guess it doesn't have to be an isosceles triangle, but it will intercept that arc. So, the measure of an inscribed angle, is 1/2 the measure of its intercepted arc. So, if here's ADC, okay, I got to back up a little bit. Okay, if you have this angle bisector, this 90 degree angle may not necessarily be there. It could be there if those are congruent. If you know those are congruent, then it would be there. I was thinking of this one. Okay, we know those aren't congruent, so an angle bisector still would be a median, but it wouldn't necessarily be a 90 degree angle there. Okay, the measure of ADB is going to be half the measure of arc AB. So if arc AB is 140 degrees, this is going to be 70 degrees, half of it. Inscribed angles of a circle theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Okay, so if we look at angle ADB, this looks kind of weird. First I see an X, but I got to color this in. There's angle ADB, and then I have angle ACB. You see the two inscribed angles here. and they are both intercepting the arc AB. So we have arc AB right here. ADB and ACB are both intercepting that. That means they're going to have the same measurement. So if this is 100 degrees, then both of these would be 50 and 50. Okay. Next one is just a vocabulary again. A polygon is inscribed when all its vertices are on the circle, and the circle is said to circumscribe. And we talked about that a lot when we did the medians and altitudes and orthocenters and circumcenters and end centers and stuff like that. So the circle circumscribes, the polygon is inscribed. Next one is if you have an inscribed triangle that goes through the center, then you have a 90-degree angle. Okay. So if you have a triangle that is inscribed, and the longest side, which would be the diameter, goes through the center, then you have a 90-degree angle. Okay? So you can draw another, you have a circle, and let's say we don't know if that is a diameter, but we do know that this is 90-degree angles. So if that's 90 degrees there, then AC is a diameter. So if that's 90 degrees, then you know AC is going to be a diameter. If this is a diameter, then that is 90 degrees right there. So it works both directions. It's if and only if. There's your if and only if. Inscribed quadrilateral, opposite angles are supplementary. That means they add to 180. Probably a formula coming up here. So E and G would add up to 180. F and D would add up to 180. If you look at their inscribed angle components, they would include the entire circle. So FED intercepts the arc FGD all the way around here. Whereas FG, angle G, intercepts the arc DEF. So between those two angles, the whole circle is included. The whole circle is 360 degrees, but remember inscribed angles are half of that, so divide by 2, so they have to add up to 180. Okay? So if they give you something like, okay, one side is 2x plus 1 and the other side is 4x minus 3, you can know 2x plus 1 plus 4x minus 3 has to equal 180, and then you can solve it from there. So you add the parts, set it equal to 180 in that time. Okay, examples, and make sure I have the assignment. Okay, so the measure of angle A, use the diagram to find the indicated measure. Measure of angle A. So A is right there. I see the triangle that CB is a diameter. So I have a triangle inscribed in a circle. The hypotenuse is the diameter. So if the hypotenuse is the diameter, then that has to equal 90 degrees. So the hypotenuse is the diameter. That has to be 90 degrees right there. Okay, they want the measure of angle C. They want this measure up here. Okay, so this is 28. This is 90, so C has to be 180 minus 28 minus 90. That's the easiest way to do that, or just take 90 minus 28. Because the two other angles for a right triangle have to be complementary. So you can just take 90 minus 28 to get that angle there. B to C, the length of B to C. Okay, here's your right triangle. The right triangle, think Pythagorean theorem. A squared plus B squared equals C squared. So BC is going to be the square root of 3.9 squared plus 7.3 squared. Square root of 3.9 squared plus 7.3 squared. And we get about 8.3. Pythagorean theorem on that one. Measure of arc AC. Okay, well there's AC. Here's the inscribed angle. AC, the intercepted arc, it subtends arc angle B down here. So if angle B is 28, this has to be twice that, so 2 times 28, we get 56 degrees. Okay. Measure of arc AB. AB subtends angle ACB. And we knew ACB is 62, so 62 times 2 is going to be 124. Now you can also take that, you know this is a diameter, so BAC, arc BAC has to be 180. We could also take 180 minus the 56 we had earlier, and you're going to get 124 as well. Okay. Question 6, name 2 pairs of congruent angles. Okay, this looks like that picture right there. Okay, inscribed angles of a circle theorem. So if we look at angle ABD, and then we look at angle ACD, you see that they both intercept this arc over here. So ABD, ACD intercept arc AD. So 2 pairs of congruent angles. We know angle ABD has to be congruent to angle ACD. The other one would be on the flip side. BAC has to equal angle BDC. BAC, same as BDC, they both intercept the arc BC. So arc BAC is congruent to arc BDC. Find the value of each variable. This is a quadrilateral inscribed in a circle. So if they're inscribed in a circle, opposite angles are supplementary. So opposite angles have to add up to 180. So opposite angles, M is opposite to 65. So M plus 65 equals 180. Subtract 65, and you get M equals 115. N plus 100 have to equal 180, so N is 80 degrees. Okay, that was it for that practice. Let's look at the assignment and see if there's anything else that pops out to me. Find the measure of angle A. That's just an inscribed angle, half that. Find the measure of angle G. So that's 70, that's 120. Remember, the whole circle is 360. So if you take 360 minus those two, they'll find the arc. Cut that in half to find that one. Okay, there's a diameter. That means NML is 180. So that can figure out what that arc is, and then the angle. RS, arc VU. Okay, that's VU. They don't want TV. They want VU, but remember you do have a diameter. So you know TVU is 180. Measure of arc WX. So you can find WY, and then you have the 110. So if you take 360 minus those two, that's going to be what's left here for arc WX. 2 pairs of congruent angles, we just did that. That is question 7. And it is question 7. How about that? 2 pairs of congruent angles. Find the measure of the red arc or the angle. So in this case, the angle. So this is theorem 1011, inscribed angles of a triangle, of a circle. Okay, kind of the same thing going on here. Okay, there's your inscribed angle. This is inscribed quadrilateral theorem. Inscribed quadrilateral theorem. Inscribed quadrilateral theorem. Looks a little bit. So like angle MJK, that's an inscribed angle. It's going to be half of these two added together. So you may have to find these two angles using the arcs. Find the two angles using the arcs. Find the value of each variable. That's just a... Okay, you got a diameter. You got a triangle inscribed in a circle. That's an inscribed right triangle theorem to look at that. Oh, it's some basic equation solving. Go for that. Okay, that's it. Hope that goes okay for you. Miss you all. See you soon. Good luck.